Students, in this class we can discuss about energy stored in an inductor. So this is the derivation. Okay, what is the energy stored in a pure inductive coil? So we have to derive E is equal to half Li square. So this is very important question in examination point of view for 6 marks. Almost most of the question paper this question is appeared for 6 marks. So now we can discuss how inductor will store energy will be discussed. Okay, so generally inductive coil means it consists of both inductance as well as resistance. That is called as an inductive coil. Okay, inductive coil means it will have L and R value, but for this derivation we are considering the pure inductance. So therefore if you consider pure inductance, the resistance value should be 0. So let us consider a coil. It's a pure inductance, and ideally it can collect as also an ideal inductor of L Henry as shown in figure. So I'm going to consider the coil E. So we are applying a sinusoidal voltage V. This V will drive a current I. Okay, so this is because of self-inductance. We already know that. Okay, the pure inductive coil. Okay, so resistance value is 0 shown in. So because of an AC voltage, an alternating current is flowing and it will produce an alternating flux in the coil. So therefore the EMF induced is given by, as per self-inductance, minus L into di by dt. It is also called as minus V. E is equal to minus V because of Lenz's law, where V is equal to L into di by dt. Okay, V is given by L into di by dt. So the pure inductance will not consume any energy. It's very important. Both inductor as well as capacitor will not consume any energy, and energy supplied to the coil is stored in the form of electromagnetic field, because change in current will take place. So therefore electromagnetic field. If change in voltage, it is electric field. Okay, so electromagnetic field. So both inductor and capacitor will not consume energy, but the energy supplied to the coil will be stored in the form of electromagnetic field. So the EMF induced will oppose the cause producing it because of the Lenz's law. Okay, so in order to establish steady state current I, so in t second work has to be done. So to overcome the opposition due to the induced EMF, the work done in dt second is given by V into I into dt, because whatever the voltage is produced, okay, that EMF will oppose the supply voltage. To overcome that, we required an additional energy to overcome that. Okay, we have to pass a steady current. Okay, the given time dt is given by work done. So dw is equal to V into I into dt. Now dw is equal to, what is V? We know V is equal to L into dy by dt. So therefore L into di by dt into I dt. So therefore we can take it as, in general, dw is equal to L into I into dt. Work done is given by L into I into dt. Now how much work has to be done in the given time dt can be calculated, is given by, we know dw is equal to okay, so dw is equal to L into I into di. So work done in t seconds is given by integral of 0 to t into dw. So time means a current, so we have to know dw is L into I into di. So we can take L constant, so therefore L into integral of I is I square by 2 0 to I. So you can simplify, will get of L I square. So this is the amount of work done in the given time. So this work done is stored in the coil in the form of an electromagnetic field, and the energy stored in the coil, inductive coil, is given by E is equal to half into Li square. This is the derivation of energy stored in the inductive coil. Thank you.